analysis. There's not a lot of problems here because you guys are going to be using this in the mole section also, and there's quite a few problems there. So just a couple to give you the idea, but what you need to remember is whenever you're using DA, dimensional analysis, you're always focusing on the units. Remember we did a bunch of silly shapes and pictures of dragons and balls and things like that. It didn't matter what those units were or what those pictures were, we still use the same approach every single time. We said if we've got something here and we want to cancel it out, let's make this a ball. If we've got a round circle, we've got a ball here, we've got centimeters there, whatever, we know we have to match it and put it here. Mathematically, that's going to cause these guys to divide through and to cancel out. That's the same approach every single time. Focus on units first, and then you can start worrying about numbers. So let's consider that while we work out these two problems. The first problem says convert 134.4 kilometers to feet. So I want to get rid of kilometers and I want to go to feet. So I'm worried about my units. I don't really care about my numbers. I do know that I have a kilometer to mile conversion factor, equivalency, and I also know a feet to mile conversion factor. So I'm going to set those up in the right way. Again, it doesn't matter if it's a ball, a dragon, a smiley face, kilometers, whatever. If it's here and I want it to mathematically cancel out, I purposely put it here. So here's kilometers, I put kilometers down here. Now I know kilometers are going to be equal to miles. I have information, I'll fill in numbers later. So I put miles up here. Kilometers are going to cancel. Now I have miles. I don't want miles, I want feet, so I got to get rid of miles. Again, if I have a ball here and I want it to cancel, I put a ball here. If I have miles here and I want it to cancel, I put miles there. So there goes my miles. Now I know miles are going to be equivalent to feet. I just have to figure out how many. So now my miles cancel. Now that I've got my units in the correct position, then the numbers fall into place. The 1.61 goes with kilometers, so I put that here, 1.61. The 1 goes with miles, so I put that next to mile. The 5,280 goes with feet, so I put 5,280 on top. And the 1 goes with miles, so I put that on the bottom. Now that my numbers are in the right spots, I take out my calculator, and I multiply any digit on top. So 134.4 times 1, let me switch to red here, times 1, still the same thing, divided by 1.61, because it's on the bottom. So I divide by any number on the bottom. Then I hit multiply, 5,280 feet, because it's on top. And then I hit divided by 1, which I don't really need to do because it's the same thing. But if you had different numbers here, you would always multiply anything on top, divide through by the bottom. Multiply on top, divide through on the bottom, and then hit equals at the very end, and you end up with about 4.1 or 4.41 feet. Oh, I forgot my exponent. Times 10 to the 5th feet. 4.41 didn't sound quite right. So when you look at your calculator, if you did this, you end up with this crazy big number, a lot of feet in that many kilometers. I ended up rounding. There's 4 digits here, so you can round to 4 if you want. I put this in scientific notation, 4.408, round that 7 up to an 8 because the 6 next to it, and times 10 to the 1, 2, 3, 4, 5, 10 to the 5th feet. If you want to round a little bit more, you can. All right, the next one. The next one is a 2-unit cancellation. So I've got kilometers per hour, and I've got to end with meters per second. So way over here, I'm going to write what I want to end with, meters per second. Now remember, meters is M, miles is MI. So I want to make sure I don't mix those up. So, eeny, meeny, miny, mo here. Do I want to convert kilometers to meters first, or do I want to convert hours to seconds first? It doesn't really matter because it's all multiplication and division. It's all going to get scrunched up together. Let's just bang out kilometers. Again, if I have a ball here and I want a ball to cancel, I put a ball down there. If I have kilometers here and I want kilometers to cancel, I put kilometers down here. Now I know 1 kilometer is 1,000 meters. So 1,000 meters is 1 kilometer. That took care of my kilometers and it got me meters on top. I like to circle that to make sure that I know that my top unit is all set. I want it to be meters. I don't want to try to cancel out meters anymore. Now what I'm going to focus on is my bottom unit, my hours. I want hours to turn into seconds. If I put hours down here, they're not going to cancel. they're going to end up giving me hours squared, which is not what I want at all. So I don't want to put hours on the bottom. If I have a ball down here that's green and I want that green ball to cancel, I put a green ball up here. If I have a dragon here and I want it to cancel, I purposely put it here because a dragon divided by dragon is going to be canceling out. Over here, if I've got hours and I want it to cancel, I don't put it down here, I put it on top. Just like my dragons, just like my balls. They're going to cancel. Now, what's an hour equal to? Please be careful when you're on the exam. So many kids, they'll say an hour is equal to 60 seconds. They're moving quickly. No, an hour is not 60 seconds. An hour is actually 60 minutes. So check your conversion factors. Make sure that you know which is which. This gets me to minutes. Minutes is still not seconds, so I want to get rid of minutes. So I put minutes up here, so purposely they'll cancel. And I know 1 minute is 60 seconds. Minutes cancels. I circle this. That tells me I have my unit on the bottom. This circle told me I have my unit on top. Nothing else persists. Kilometers are gone, hours are gone, minutes are gone. Down here, hours are gone, minutes are gone, and kilometers are gone. So I just have seconds left, minutes or meters over seconds. And when you run the numbers, this divided by 1 times 1,000 divided by 1 times 1 divided by 60 times 1 divided by 60. Multiply anything on top, divide through by the bottom. You end up with 37.3 meters per second. So in 1 second, we're going to go 37.3 meters. All right, real quick, bang out the densities. Densities you should be able to do. These are not solved for density. These problems give you the density, but it says what's one of the other missing variables. So I tell you in the first problem, the density is 3.45 times 10, or I'm sorry, grams per cubic centimeter, and you know the mass. You've got to figure out the volume. So here's what I tell everybody to do. Take the 3.45 grams per cubic centimeter, rewrite it. I hate the slash marks. They screw kids up. Rewrite it as a straight line conversion factor. Put the 1 down there, and now it looks like something you can use in your equation. We've got grams here. If you want grams to cancel, you put grams on the bottom. Just like if you have a ball here and you want the ball to cancel, you put the ball on the bottom. It doesn't matter what unit it is. Grams and grams. You want to find the volume, and in the conversion factor we have centimeters cubed, so that's the unit we're going to use. If this said milliliters, I put milliliters here. It doesn't really matter because they're equal. All right, so now I got to plug the numbers in. 3.45 goes with grams. Grams happens to be on the bottom. That's how I know to put 3.45 on the bottom. And the 1 goes with the cubic centimeters. That's how I know 1 goes on top. So 34.4 times 1 divided by 3.45, and that's 9.97 cubic centimeters. So there's your number on top, or your final answer rather. Over here, use a dimensional analysis to determine the mass, so we don't know how many grams, but we do know our volume is 50 milliliters, and we do know the density. Again, I hate slashes. Rewrite this. Grams over 1 milliliter. Get rid of that. So you don't see it anymore, you don't look at it, you don't try to use it as a unit together. It's grams over milliliters. Now I want milliliters to cancel. Just like if I have a ball here and I want a ball to cancel, I put it there. If I have milliliters and I want milliliters to cancel, I put it there. I want to find out grams. I don't want that to cancel, so I put that on top. And I look at my numbers. 0.75 goes with grams. The 1 goes with the milliliters. And that's it. 50 times 0.75. And you come out with 37.5 grams. And there's your answer for the mass for that problem. All right, off to the mole.